Good morning, students. Today we are going to discuss about the implementation of decision tree. So, as you know that how decision tree works. Decision tree works in the basis of certain condition, and according to the condition, we are trying to construct a decision tree which will classify my data into different classes. So, we'll just take a simple example to just give an overview, so you can recall what we have discussed in previous class. Like suppose I want to take a decision that I should sleep or I should go to a restaurant or I should eat a hamburger at home. Okay, so I want to take a certain decision at this point of time. So first of all, I have to ask question to myself that I'm hungry or not. If I'm not hungry, so I should go for a sleep. Otherwise, if I'm feeling hungry, then I have an option that I can go to restaurant or I can buy a hamburger. So to go to a restaurant, I should have minimum $25 in my hand. So if I'm having, I can go to the restaurant. Otherwise, I have to buy a hamburger. So I have divided my data into different classes as per the conditions which are there. So in this way, decision tree works, and we have discussed example that how we can construct a decision tree. So in today's class, we are going to discuss how I can implement decision tree in Python. Okay, so we are going to discuss the lab session here. So just a minute, I'll show you. So when we are talking about decision tree, again I'm considering the same data set what we have used in KNN, the diabetic data set. There we have a multiple columns like pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, function, age, and the final is outcome. So I gave a clear idea about the data set in the K nearest neighbor algorithm implementation. So if first you listen that video and then go with this video, so you will understand that how the data set works here. Okay. So what we are doing first of all, we are importing all the libraries which is useful for my implementation, and all these library work of these libraries also I have discussed in KNN. So I'm not going to discuss again here. Fine. So these are the libraries which we have imported. Now, first of all, I have to take my data set. So my data set is available in my reader in my C drive. So I'm just uh, importing my data set here using pd.read CSV file, and finally I'm displaying the first 5 line of my data set using head function. So I'm using head and I'm displaying my data set, and same time I want to display the length of my data set. So my data set consisting of 768 patients details here. Fine. The same way we printed here information about the dataset using dataset.info. So it is giving me some information related to dataset, that what are the different columns are available in the dataset, what are the data type of that dataset, and how much memory it is occupying. Okay. After getting the description about the dataset, now what is the next task? What we have to do generally? The same we discuss in KNN. What we are doing, we are dividing the data into training as well as testing. So I need my input features. I have to segregate my input feature and the target variable. So first of all, I'm taking all the input features. So what is my input here? These are my input variable from pregnancy to age. These are my input variable, and the last column is representing output variable. So I'm splitting my data x equal to dataset dot I log index location. I'm taking all the rows of my data set from column 0 to 8. So it will not consider the column number 8. It will take only 0 to 7 because we are splitting the data. Okay, we are using slicing of the list. Now I kept all the features in X variable, and the outcome variable or a target variable I want to keep in Y. So same I'm doing for all the rows. Outcome variable I want to keep in Y variable. So I have taken input features in X and output or target variable in Y. Now I want to split my data into training and testing. So I using 4 variable X train, Y train, X test, and Y test, and I'm splitting my data. For splitting my data, I'm using X and Y data set, and X and Y where my data is available, features and the outcome variable is available. The same way, I'm keeping random state equal to 100. Okay, and test size I'm keeping 0.3. It means 30% data I'm using for training, and the remaining 30% I'm using for testing, and the remaining I'm using for training purpose. Fine. Now as we are implementing decision tree classifier, so I'm importing this. I have imported decision tree classifier library here. Okay, as you can see here, we imported that library. Now I'm calling the same function, and to construct a decision tree, I'm using a criteria which is entropy, which we discussed already. To construct a decision tree, I'm using here entropy. So we discussed the same concept in theory session. So please go through with it if you don't know how entropy works. We initiated random state value equal to 100, and I want my tree depth should be maximum 3. I don't want to make my tree more complicated or complex. So that's why I'm setting my depth of the tree is maximum 3, and minimum sample leaves which I'm constructing to make it as a decision to take a decision tree is 5. So these are some of the hyperparameters which we can tune or which we can change here. So you can play with all these hyperparameters. Okay. Now I'm fitting my model with training data. So I fit my model using X train and Y train. After that, after fitting the model, it means I have trained the model, and now I want to do the prediction after the training. So I'm doing the prediction here. So for prediction, I'm using test data. So which is there in X test. So I'm using Y prediction equal to CLF underscore entropy dot predict, which is going to predict my data and keeping my result in Y prediction. So this is my final prediction result. So I have classified my data into two class, 0 class and class 1. Okay. So there are two classes, 0 and 1. And finally, I want to create a confusion matrix. So we know that how to create a confusion matrix. So I'm creating a confusion matrix between actual value and the predicted value. And I want to print the confusion matrix. And the same time, I want to print the F1 score here. So this is my confusion matrix. This 140 is representing true positive. This 27 is representing true negative. 10 is representing false positive and 54 is representing false negative, and my final F1 score value is 0.45. So if you observe here, the F1 score value is lesser than when we applied the KNN. So decision tree is not giving more good result as compared to KNN. So because we applied KNN on the same data set, we applied KNN, we applied decision tree, but KNN was giving me better results compared to decision tree. So I can take a decision here that for this particular data set, maybe KNN works better than decision tree. So this is all about the decision tree. I hope it is clear to you. Thank you.